I want to speak now about the idea of periodic trends. We'll be discussing periodic trends in great detail when we finish studying quantum mechanics and learn specifically where the electrons are. But we know enough at this particular point in terms of understanding a periodic table to be able to say, you know what, on this far left-hand side of the periodic table here, these species typically tend to form cations. They typically tend to lose electrons. Whereas over here on the far right-hand side of the periodic table, these species typically tend to form anions. They typically tend to gain electrons. And in fact, that general kind of idea there falls out of the desire for these elements to become noble gas-like by losing electrons, these by gaining electrons. So that when we think about trends, we can actually look at the periodic table and have these kinds of from left to right sorts of ways of defining what's going on. So for example, let's take a look at what it means to be a metal. Metals by nature typically tend to want to lose electrons and become cations. Metals by nature have certain sorts of characteristics in terms of being lustrous. They tend to share their electrons. Whether or not something is metallic can actually be assigned to where it is on the periodic table, with the most metallic materials being over here on the left-hand side, and in fact in the lower left-hand corner of the periodic table. And as we move across the periodic table over to the other side, we become decreasingly metallic, till we get to the point over here where I'm looking at these green-colored species right here. These right here are actually known as nonmetals. These do not want to lose electrons, they want to gain electrons. Now, sitting along here in this region between the metallic and the non-metallic material are materials which are, well, they can go either way. These are known as metalloids, and they're very important in semiconductor industry. Well, that notion about whether something does or doesn't want electrons, and therefore defining its metallic character, plays into lots of other kinds of arguments for trends. So here's a trend, the trend to want to give up an electron. This is known as ionization energy. And the lowest ionization energies are down here in the lower left-hand side, because these would desperately love to give up electrons and become like a noble gas, become a cation that way. And over here, these desperately want electrons so that they can be like a noble gas. So in the same way that the trend for metallic character goes this way, the trend for ionization energy also goes this way. Let's talk about affinities for electrons, the opposite of wanting to give them up. Let's talk about wanting them. Electron affinity is going to be very low over here on the left-hand side of the periodic table. It's going to be very high over here on the right-hand side of the periodic table. There are lots of other trends we can talk about: electronegativity, the sizes of atoms. All of these will be discussed later. But it's important to appreciate that something as simple as knowing about the valence electrons as you move from the left to the right across the periodic table, and their desire to be noble gas-like, is what allows us to create these general sorts of arguments for the trends in a periodic table. This is valuable because it begins the process of our not having to memorize everything, and that's the key thing to appreciate here. I don't have to memorize what stuff is metallic. I don't have to memorize what the rankings for ionization energy are. So for example, if somebody said to me, why don't you rank cesium and yttrium and chromium on the basis of ionization energy, I would say, well, the stuff over to the far left-hand side of the periodic table has the lowest ionization energy, and then yttrium, and then chromium in that particular order. So knowing the trends and knowing the rules describing the trends allows us to do a lot of relative comparison of the properties of the elements and be able to make intelligent arguments for them.